In this video, we'll balance the net ionic equation for K2CO3 plus FeCl3. This is potassium carbonate, and this is iron 3 chloride. The first thing we need to do is balance the molecular equation. This is the molecular equation. I have 1 iron here and 2 here. So I'm going to put a 2 in front of the iron 3 chloride. But now I have 2 times 3, 6 chlorine atoms. So I'm going to put a 6 in front of the KCl, 6 potassiums. Let's put a 3 here. And this equation is balanced. So at this point, we can move on to writing the state for each substance. If you know your solubility rules, potassium compounds are very soluble, even though carbonates in general aren't. But potassium, it's a group 1 element, so that's going to be soluble. We put a little AQ. Chloride's very soluble here, so this iron 3 chloride will be aqueous. We have potassium chloride, that's aqueous. And then we have this carbonate here. Iron's not in group 1, so this is going to be insoluble. We're going to put an S after it. That's going to be a solid. It'll fall to the bottom of the test tube as a precipitate. So this Fe2CO3 iron 3 carbonate, that's going to be our precipitate here. Now we can split the strong electrolytes into ions, and this will give us the complete ionic equation. Potassium is in group 1, so it'll be 1 plus each one of them. And the whole carbonate, that's 2 minus. Good one to remember. 3 times 2, 6 of these potassium ions. And I won't write the states now. Let's write those later. Plus 3 carbonate ions. For the iron, it's a transition metal, so we don't know the charge. But the chlorine, that forms the chloride ion, that's 1 minus. We have 3 of them. The iron has to be 3 plus. So we have 2 of these iron 3 ions. And then we have 2 times 3 here. 2 times 3, that gives us 6 chloride ions. So these are the reactants in our net ionic equation. For the products, potassium group 1 says 1 plus, the chloride 1 minus. So we'll have 6 potassium ions, just like the reactants, plus we'll have 6 chloride ions, also just like the reactants. And then we'll have this Fe2CO3. It's a solid. This is our precipitate here. So we're not going to split that apart. Since it's a solid, we're going to keep it together. And this is our complete ionic equation. Now we can cross out spectator ions. They're on both sides of that complete ionic equation. So as I look at the reactants here, and then I have the products down here, I have 6 potassium ions in the reactants and again in the products. Those are spectator ions. We'll cross those out. And then I have 6 chloride ions in the reactants and 6 in the products. Spectator ions, which we'll cross out. What's left? That's our net ionic equation for K2CO3 plus FeCl3. I'll clean it up, write the states. We'll have our net ionic equation. So this is the balanced net ionic equation for potassium carbonate plus iron 3 chloride. If you count the atoms up, they're balanced. And if you look at the charge, it's also balanced. 3 times 2 minus is 6 minus. 2 times 3 plus is 6 plus. So those add up to 0, net charge of 0. This is neutral, net charge of 0. Sometimes you'll see the positive ion here written first. It really doesn't matter. Maybe it looks a little bit better. But that's it. This is the balanced net ionic equation for K2CO3 plus FeCl3. This is Dr. B, and thanks for watching.